Now, the topic is about the partial differentiation or just simply partial derivatives, wherein we have to consider a partial differentiation if the given function consists of more than one independent variables. Like in this case, we have two independent variables as x, y, so we have to find the two partial derivatives of the function. So one is with respect to x, the other one is with respect to y. So this is our definition for the partial derivatives when it is with respect to x. So this is just simply the limit of the function as delta x approaches to 0, and this is equal to the function of x plus delta x and y minus the function of xy over delta x. And if this is limit exists, so then we can consider that this is the partial derivative of the function xy with respect to x. So similarly, since there are two independent variables, similarly for the y variables wherein we can consider the partial derivative with respect to y. So this is also the limit of the function, but this time this is as delta y approaches to 0. So this is now also equal to the limit of the function x, but this time this is the y plus delta y minus the function f of x and y divided by the delta y. And again, similarly, if this limit exists, so then the partial derivative of the function xy with respect to y is obtained. And in finding the partial derivatives of this function consists of more than one independent variable, so then the other variable will be considered as constant. The other definition of the partial derivative is that this is also the rate of change of the function with respect to x and the rate of the function with respect to y. And the process or method in finding the partial derivative is called as the partial differentiation. Now, in this topic, partial differentiation, these are the notations used. As you can see here, there are several notations used for partial derivative of the function. So, we can consider the operator d, or just simply as d is of x with respect to function xy. But then again, the common here is the partial derivative of the function with respect to x. So this is the common. d1 means the first element with respect to x and the d2 with respect to y if there are two functions as x and y. Now in these examples, the given, the unknown should be indicated. So for example, number 1, we have two independent variables here. And then we have to look for the partial differentiation with respect to x and with respect to y. So let us answer these examples. For number 1, we have the function xy, and this is equal to 3x squared minus y squared. And then we have to look for the partial derivative of the function with respect to x, and the other one is with respect to y. Now, in finding the partial derivative of a certain function, the other variable should be considered as constant. So like in this case, if we will look for the partial derivative of the function with respect to x, we have to consider the y as constant. So then, if the y is constant, therefore we can have that the answer is 3 times 2, and that will be 6, and then the derivative is 6x. And then similarly, if we have to look for the partial derivative of the function with respect to y, we will consider x as constant. So if x is constant, so we have it here as power derivative, we have bring down to, that will be negative 2y. Then the next example is we have the function with respect to x, y, z. So we have three independent variables here, and then the given function is ln of x squared over z squared. And then as you can see here, we use different notation for the partial derivative. So d1 means with respect to x, d2 means with respect to y, and d3 means with respect to z. So if we will find the d1, means we have to consider the y as a constant because we have to find the derivative of this function with respect to x. So we have to recall that the derivative of the ln or the loan will be just simply 1 over u, and this is the u given of the function. And then we have to multiply the derivative of the function. So this is just simply 1 over x squared over z squared, and then derivative of this u when y and z are constants. So we can only differentiate the x squared here. So derivative of x squared is 2x, and then constant as y z squared. Then all we have to do is just simplify this. So if we will multiply the numerator by the reciprocal of the denominator, so it becomes z squared over x squared y, and then to be multiplied with the derivative of the u, then obviously we can reduce the z squared here, and the x, and the y. So finally we have only as 2 over x. So then the derivative of the function with respect to x is just simply 2 over x. And then when we find the derivative of the function with respect to y, which is denoted as d2, so this time we have to consider the x and z as the constants. So similarly, for the derivative of the ln, this is just simply 1 over u, and then we have to multiply with the derivative of the u, but this time the x and z are constants, so we can only differentiate the y here, and the derivative of y with respect to y is 1. So this is your answer as the derivative of the u, which is x squared over z squared. And then simplifying again, we have to multiply the numerator by the reciprocal of the denominator, and that will be z squared over x squared y, and then multiply by the derivative of the u. Here we can simplify, we can reduce the z squared here and the x squared, so remaining just simply 1 over y. So the partial derivative of the function with respect to y is just simply 1 over y. Then moving on, when it comes to with respect to z, this time the x and y are constants. So then again, we have to find the derivative of the loan. So this is just simply 1 over u, and then multiply by the derivative of the u. But then again, this is with respect to z, therefore the x squared and y squared are constants. So how to differentiate the z squared here? We can express as power derivative. So then it can be as raised to negative 2, then bring down negative 2, and then less 1 from negative 2, and that will be negative 2, negative 1, so negative 3. Or you can bring it down again as positive exponent, so this is z squared. And then simplifying, we have to multiply again the numerator by the reciprocal of the denominator, and that will be z squared over x squared y, and then multiplied by the derivative of the u. So then similarly, we can reduce the x squared here, and then the y, and then z squared over z, so this is simply over z. Therefore, the partial derivative of the function with respect to z is just simply negative 2 over z. And then another example for number 3 is that this time we will consider a variable, a dependent variable as u, wherein this is given as the exponential function e raised to x squared minus 2y cubed. Here we have to look for the partial derivative of the function u with respect to x, and the other one is with respect to y. So similarly, from the previous example, that we will consider the y as constant if we will differentiate the function with respect to x. So this is again, we use this notation. So we have it here, the partial derivative of the u with respect to x, and going back to or recalling to the derivative of the exponential, this is just simply e to the u, and then multiplied by the derivative of the u. So we have it here, e to the u, and then we have to multiply with the derivative of the u, but if y is constant, we can only differentiate the x squared, which is 2x. And then all we have to do is just simplify it as 2x, and then multiplied by e raised to x squared minus 2y cubed. And then similarly, if we will find the derivative of the function u with respect to y, so this time we have to consider x as constant, then this is simply as e to the u again, derivative of the e raised to u is just simply e to the u, or just simply e raised to x squared minus 2y cubed, and then multiply with the derivative of the u where x is constant, so we can just simply differentiate the negative 2y cubed, which is simply this negative 6y squared, or simply just consider as the partial derivative of the u with respect to x is just simply negative 6y squared and then multiplied by e to the u. And lastly, for number 4 example, this is the function xy, and the given is e raised to 2x cosine y squared minus e raised to y squared sine 2x. So here we have to look for the partial derivative of the function with respect to x, and the other one is with respect to y. So if we will find the partial derivative of the function with respect to x, then again we have to consider the y as constant. So from the given, if y is constant, so we can consider this cosine y squared as coefficient. So this is just simply coefficient, and then just evaluate or get the derivative of the e raised to 2x, which is e to the u, e raised to 2x, and the derivative of 2x again, and that will be 2. And then on the second term, if y is constant, then the ey squared is constant. So you can consider this as literal coefficient or as coefficient, constant coefficient. And then you can just simply differentiate sine 2x, and derivative of sine is cosine 2x, and derivative of 2x is 2. So you have it here that for the partial derivative of the function x with respect to x, you can factor out the 2 in order to simplify it. So we have e raised to 2x cosine y squared minus ey raised to square y squared and cosine 2x. And for the partial derivative of the function with respect to y, this is simply consider as x is constant. So this time we have to consider x as constant. Therefore, the e raised to 2x will be constant, and then all we have to do is just differentiate the cosine y squared. The derivative of cosine is negative sine y squared, and then we have to differentiate the angle y squared as 2y. And for the second term, sine 2x here will be considered as constant because x is constant, and then all we have to do is just differentiate the ey raised to square. And then derivative of e raised to y squared, so this is simply e to the y, and the derivative of y squared as 2y. And then simplifying, we have a common factor here as 2y, so we can factor out the 2y here and minus, so we have factor out negative 2y, so it should be multiplied by e raised to 2x sine y squared, and this is plus ey raised to y squared sine 2x.